Hi, in this video, we'll be looking at what we refer as a number basis. So when we talk about the number basis, we're actually looking at the basis upon which people count. For instance, in some traditions, some people count in tens, some people count in 5, some people count even in 25. So when we talk about the counting, we are talking about the base upon which you place the value. For instance, when we want to count in 10, we have a number like this. Supposing we have, let's say, we have 6,523. So this is a number we have, and this number is in base 10. So to actually see that this number is in base 10, we look at the place value of this number. For instance, we recall that when we want to place in value, we remember that the last digit by the right is always in units. So here is a unit. Then the next one we have here is in tens. Then the next digit is in hundred. And finally, the next digit now is in thousand. So now we have given the place value. So we're actually looking at what does this really mean. So we look at this. Remember, we are doing the counting in tens. So this number now, 6523. So what it means is that this could be written. So here now, on the 6. So when we come up here now, we see that 6 is placed under 1,000. So what it means is 6,000, which is the same thing as 6 times 1,000. Okay. So we look at the next digit. The next digit, if you look at this, is 5. And you will see that 5 is placed under 100. So what does it mean? It means we have 500. So which we can refer as 5 times 100. Then the next one we see, the next digit we have there is 2. 2 is placed under 10. So what it means there that we have 2 tens. So 2 tens, which we know, we now write as 2 times 10. So it means 2 tens, which is 2 times 10. Then finally, we have the last digit. The last digit is 3. 3 is units. So when we talk about units, we look at it as 1. Okay. So with that now, we can say that this 3 is under units. So 3 is under 1. So we have only 1 3. So which we can now write as 3 times 1. Okay. So we can simplify this further. So we look at this now. So here we have, you agree with me that here we have 1,000, and we recall the law of indices. So remember that 1,000 can be written as 10 times itself 10 times itself again 10. So we have 10 multiplying itself 3 times. So by the law of indices, this is the same thing as 10 cubed. Okay, by the law of indices. So with this now, we can now write this as 6 times. So our 1,000 now, this 1,000 now can be written as 10 cubed. So write this as 10 cubed. So we move on. Here again, we have 5 times 100. So we first of all write our 5. So 5 times. Now our 100, this 100 is the same thing as 10 times 10. So 10 times 10 is the same thing as 10 squared. Okay. Then finally, here, the next one, here we have 10, just 10. You remember again that the law of indices, that any number raised to power 1 is that number itself. So what it means is this, that 10, so this 10, I can also write it as 10 raised to power 1. Okay, so this our 10 now could be written as 10 raised to power 1. So we can now write this as 2 times 10 raised to power 1. Then again, the last one here, when we come over, here is 1. How do we deal with it? We'll go back to the law of indices. The law of indices says that any number raised to power 0 is 1. So in particular, 10 raised to power 0 is equals to 1. So remember, like I said earlier, that we are counting in tens. So that's why I want to leave the basis, the place values, to be in base 10. So with that, we can write this as 3. Now instead of writing 1, because we know that 10 raised to power 0 is equals to 1, so we replace 1 with 10 raised to power 0. Okay, so what have we done? So what we have done is nothing else but we have been able to express this number in powers of 10. So now, the whole thing we have here now, so this now has been written. So this we can say that we have written this in powers of 10. So this is in powers of 10. So this means that we are counting in tens. So actually, whenever we have any other number in a different base, we can also count in that base. Maybe we'll look at another example now. So now in this example, we want to count in base 5. Remember I told you that some traditions count in base 10, some count in 5s, and so on. So the previous example, we are counting in tens. Now, supposing we want to count in 5, so we look at an example. For instance, we have 432. This 432, let's say, is in base 5. So we write it like this. So when you are indicating base, you can write as a subfigure. You can write it like this. This is base 5. Okay. Then some other person might decide to write 432. Instead of writing it in figure, that is the base, you can also say 10. You can write it in words. So you can write it in this form. So this means this should be 5, sorry. So this is 5. So you can either write it in figure or you write it in words. Okay. So now we want to count in 5 because here is in base 5. So what it means is this, we are counting in 5. So like we did previously, we have to look at the place values. So again, like we did previously, the place value here is in units. So this one is always the units. Then the next one, remember, in the previous example, remember that if you are counting in tens, after the unit, the next one is in tens because you are counting in 10. But here we are counting in 5. So the next one should be 5. So here we can write it, this is 5. Okay. Then the other one, remember, is now it becomes the multiples of 5 because you are counting in 5. So the next one should be 5 times 5, which is 25. So here is 25. So here we have 25. So the first one is units. You can write it fully. So the unit, the other one is 5, then the other one is 25. This is simply because we are counting in 5s. So now, to expand this now, so we do the expansion in base 5. So this is what we have. Okay, so now what we have, so at this one, we see that here, so this unit, this 4, remember that 4 is under 25. So what we now have is 4 times 25. So we are just following the same approach as it was in the case of 10, but here is now in 5. So then the next one, so the next digit now, the next digit is 3. 3 is placed under 5. So what it means is 3 5. So it means 3 times 5. And finally, the unit. So 2 is under unit. That means that we have only 1 2. So with that now, one can write this as 2 times 1. Okay. So we can go further to expand. So here the law of indices will help us. So here we still have our 4 times. Now here we have 25. But remember, we are counting in 5. So we know that 25 is the same thing as 5 times 5. And by the law of indices, we know that this thing is the same thing as 5 squared. Okay. So now 25 now has become 5 squared. Okay. Then here we have our 3 times. Here again, we remember again that any number raised to power 1 is that number itself. So we know that 5 raised to power 1 is the same thing as 5. Okay. So what it means is that this 5 could be written as 5 raised to power 1. We write this as 5 raised to power 1. Then here 2 times. We can place 1 in base 5. Remember that any number raised to power 0 is 1. So in particular, 5 raised to power 0 is the same thing as 1. Okay, so that means that we can write this as 5 raised to power 0. So this 1 can be replaced as 5 raised to power 0. So you have seen that everything now we have here now is now in powers of 5. This is 5 raised to power 2. This is 5 raised to power 1. This is 5 raised to power 0. So everything now are in multiples of 5. So they are multiples of 5. So now we have done the counting. So as you can see now, this counting is done in 5. So we can say that this is done in powers of 5. So we can say that this is powers or multiples of 5. This is in powers of 5. So that means we have done the counting in 5. So this is actually what we mean by number basic. So in the subsequent videos now, we're looking at more appropriate examples.